Okay, guys. Hello, discrete math students. How are you? This is Mr. Lewitt. We're just going to do a very quick introduction to Python and Racket today. Um, I'm going to try to keep the video reasonably short. I hope the video is not longer than 45 minutes. Um, if the video gets to be longer than 45 minutes, I may just have to cut it short, okay? Um, so yeah, some of you have emailed me with concerns about downloading and installing Mathematica. And I did contact the company that that makes and sells Mathematica, Wolfram Research, and they told me that Oakton Community College forgot to renew the site license. The site license expired on August 14th, and Oakton forgot to renew the site license. I think that was just a little error on the college's part. I did email a couple of administrators at the college, and hopefully they will renew Oakton's Mathematica site license soon, like within the next week or so. Um, the woman that I spoke to at Wolfram Research told me that she will contact the sales rep who's in charge of the schools in this area, and the sales rep, she'll try to encourage the sales rep to give us an extension of a few weeks, which should help. Um, because I think, well, we'll see how it goes. We'll see how it goes. Hopefully, there won't be a problem. If there's a problem and Oakton chooses not to renew the site license, then we're just going to do the course with Python and Racket. But I'm pretty sure that was just a little mistake on the part of the college. I'm pretty sure that that was an oversight on their part. And if that's the case, they will probably renew the site license soon, like either this week or next week, and then you should be able to get Mathematica without a problem. So just be patient, okay? Just be patient, and we'll figure it out, okay? So in the meantime, we're gonna do one problem. We're gonna do it in Python, and we're gonna do it in Rackets. All right. So let's look at the homework. Let me see. This is the first homework question in chapter 3. Question, find max, which is short for maximum, find maximum element algorithm. Identify the steps used in algorithm 1 to find the maximum element in the following finite sequence. 1, 8, 12, 9, 11, 2, 14, 5, 10, and 4. Excuse me. Okay. So they're using, a classic algorithm, algorithm 1, procedure max, and we have this many integers, a1, a2, up to an, okay? And we start out with the assumption that the maximum element is the first element of the list. For I is equal to 2 to n, where n is the length of the list or the length of the array, if max is less than the list or array element at that particular index, then the new max is equal to ai. Return max. Max is the largest element. Okay, so this, hold on just one second. Here we go. Okay, so this approach is often called, well, you can call this procedural. You can call it procedural, or you can call it the iterative approach. The iterative approach. And they both kind of mean the same thing. Excuse me. I took Tylenol PM last night and I'm still very sleepy. So, okay. Let me turn on some lights. Okay. So this is your typical procedural or iterative algorithm, and you'll find this used a lot in languages like C and C++, and of course Python, okay, and Ruby, and JavaScript, and of course Java. Okay, and those languages are great, but in this course I want to emphasize functional programming and recursion. Recursion is a big part of functional programming, and I will explain more of that in future videos. But yeah, for loops and while loops and do loops are good, but there is another approach that we can sometimes use to solve these problems, okay? So, first of all, let's see. First let's answer the question. So the max is 1. At index 2, the max becomes 8. And hold on one second. It's definitely not the last one, I can tell you that. So the max is 1. Index 2, okay, let me see. Okay, so then at index 2, the new maximum is going to be 8. Let's see. So 8 is less than 12. So the new max is going to be 12, and that happens at index 3. Although the way they're counting this is a little strange, but that's okay. 3, 4, 5, 6, and then at 7 we have the new max of 14. Okay, I believe the way they're counting this is a little bit strange. I think it's going to be the first choice. Let me see something here. Because these two choices look pretty attractive as well. It's definitely not the last choice, because according to the last choice, you don't reach your maximum until the very last index, which is not correct. So let me see what they say. Yeah, that is correct. You have, by the way, you have three attempts on each question. Okay, I gave everyone 3 attempts. So, yeah. But yeah, so this is the correct answer. So we start out with the max being assumed to be 1, and then the index goes up to 2. Now the max is 8. And then you have 3, 4, 5, and 6. And so at index 3, we know that the maximum is 12. And the maximum remains 12 throughout these indices, 3 and 4 and 5 and 6. And then at index 7, you have 1, 2, 3, 4, 5, 6, 7. At index 7, the new maximum is 14, and 14 remains the maximum for the rest of the list. So I think I see how they're counting. What's also strange about this, guys, is that in your book, they start counting at index 1. That's like Mathematica. Mathematica starts counting at index 1. But in Python and in Racket, actually in most programming languages, we start counting our lists, our arrays in our lists at index 0. but your book starts counting at index 1, which is just like Mathematica and also the R programming language. But in most programming languages, we start at index 0. Okay, so that can be a source of confusion too. Okay, now, excuse me, how, forgive all the yawning, I'm a little sleepy. How would I code this up in Python and in Racket? But I'm going to use recursion. Instead of a for loop, I'm going to use recursion. Okay, so first Python, which is probably familiar to most of you. Hold on one second. This is a little bit in, oh, wait a minute. I can't seem to move my picture here, but that's okay. That's weird. Okay, well, that's okay, I guess. All right. For right now, it's okay. All right, so okay. 1A12, 1A12, 911-2, 14-5-10-4, 14, 5, 10, and 4. Let's see, 14, 5, 10, and 4. Enter. Let's do this. Let's write a function. Define is how you define a function in Python, right? Find maximum. And let's say the name of my list is x's. The name of my list is x's. Okay. And we're going to, actually, before I even do this, let me show you something. My list 0 should return 1. My list 1 colon gives me back everything in the list except the first element. Right? So what if I were to do this? My list 1, 1, 1. Okay, so what I'm really doing is I'm taking the tail of the list. So the first tail is this part, and the next tail is this part, and the next tail is that part. So I'm getting 9, 11, 2, 14, 5, 10, 4. Right? And if I continue doing that, what am I going to be left with? Eventually, I'm going to be left with the empty list. The empty list, okay? Now, we don't want that because you can't take the maximum element of an empty list. But you can take the maximum element of a list that only contains one element or one number, all right? So that's going to be 4. So if I give my function, if I provide my function, with this list, well, there's only one number in it, and the maximum is going to be 4. The maximum is 4. Because there's only one number in there. There's no other number. There's no other number. It doesn't make sense to give my function the empty list. What am I going to do with an empty list? There's nothing inside of it, right? So there's no maximum number. There's no maximum number. Okay, but if I have a list with one element, right, then I know that one element, of course, has to be the maximum by default. Okay? All right. So let's get back to defining the function, okay? Find maximum of x's. Okay, and x's is just the name of my list. It's a list of x's, where x is a number, x represents a number. If the length of x's is equal to 1, then return x's 0. Otherwise, the head of my list is x's 0. Okay. And then, let's see, what should I call it? Min value is equal to max value, Max value is equal to find maximum of the rest of x's, okay, which is a recursive call, okay? This is a recursive call because I'm calling the function on the rest of the list. That is a recursive call. That is a recursive call. It's a recursive call because I'm calling the function on the remainder of the list or the tail of the list. Okay? So then, if the head is greater than the max value, where the max value is the the max value is the maximum of the rest of the list, then return the head, else return max value. Find maximum my list. What is that maximum going to be? 1, 8, 12, 9, 11, 2, 14, 5, 10, 4. That's going to be 14. The max value should be 14. Okay, let's see if that's true. It is 14. Okay, that's the maximum value. So let's try this with another list. From random, import, is it randint or random int? I think it's randint. So let's see. Randint, I'm going to choose random numbers between 0 and 100. For blank, I don't care what variable name I'm going to use. I'm not going to use the variable name. For blank in range 20. This will be a new list. New my list. Let's see. Pretty print is off. So new my list. There we go. 62, 33, 59, 14, 72, 18, 51, 87. Okay, let's see. Can I eyeball the maximum here? I don't know. Let's see. 62, 33, 59, 14, 72 now is my new maximum. 18, 51, 87 is now the new maximum. 71. It looks like 87 is my maximum. Let's see. 62, 33, 59, 14, 72, 18, 51, 87, 71, 7, 80, 23. Yeah, I believe this is the maximum of the list. That's the maximum of the list, okay? So then, let's see, find maximum new mylist. It's 87. Well, what do you know? Notice I used conditional statements. I used conditional expressions here. Okay, if else or if then else, whatever you want to call it. Notice I didn't use a for loop. So this took the place of the for loop. The recursive call, one second. The recursive call took the place of, hold on one second. Took the place of the for loop. Okay, I'm writing with my trackpad, so it's a little bit awkward, but that's okay. That's an F. The recursive call took the place of the for loop. Okay, let's try the same thing in Racket. Very similar, although the syntax is very different. The concept is the same, and actually Racket supports recursion much, much better than Python does. Racket supports recursion much better than Python does, but I don't want to talk about that right now because then the video is going to get even longer, okay? So, okay. Let's talk about Dr. Racket. Dr. Racket is the IDE for Racket. Most people who use Racket, they use Dr. Racket. You really don't have to, but you should. For this class, you really should. Yeah, okay. Okay, same idea, except the notation is very different. So here, this is how I define a list. 1, 2, 3, 4, 5, 6, right? Define my list. In Racket, it's very typical, it's very common for Racket programmers to put hyphens or dashes in the names of variables and functions. You really shouldn't call it a variable, you should call it an identifier, not a variable. Let's call it an identifier. My list is 1, 2, 3, 4, 5, 6. Okay. What is the car of my list? It's the first element. What is the cdr of my list? It's everything except the first element. Cdr, oh, one second. Cdr of the cdr of my list. Okay, escape P. Escape P gives you the command, gives you what you entered above. Escape P gives you what you entered above. Cdr, let's do it again. Escape P, let's do it again. Escape P, let's do it again. Escape P, let's do it again. Now we have an empty list. Okay, but remember, for this problem, it doesn't make sense to have an empty list. It doesn't make sense to have an empty list. You want to have a list with at least one element in it. So, okay, let's define our function. Define find maximum of x's. Now for this, I'm going to use pattern matching. I don't have to, but I think it's a good idea. Why not? match x's. This means match x's with a list that contains 2 or more elements. Okay? 2 or more elements. Let the head be equal to the car of x's. And what should I call this? Max value will be find maximum of the cooter of x's. Oh, 1 second. There we go. Okay. So the head is going to be the first element of my list. And I could say max value of tail. Okay, we could be more, let's give the identifier a better name. Max value of tail, although that's a very long name, but that's okay. Find maximum of the rest of the list, which is the cooter of x's. Okay. So now I have an if expression. This is prefix notation. The operator comes before the arguments. If the head is greater than max value of tail, if the head is greater than the max value of tail, give me back the head, otherwise give me back max value of tail. And believe it or not, that's exactly what we did. That's exactly what we did in Python. Okay. Now, what if our list contains 1 or more elements? Now, this is really important for you to understand. This actually means 1 or more. This means 1 or more elements. Okay? 1 or more elements. However, what's really important to understand is if your list contains 2 or more elements, your list is going to match this particular case first, which means if your list matches this case, then you can be sure that there's only 1 element in your list, not 1 or more. There's only 1 element because this means 2 or more. So if your list matched this expression first, your list contains 2 or 3 or 4 or 5, more than 2 elements. By the time your list matches this case, there's going to be 1 element left in your list, and that's going to be the end of the subject. That's the end. That's when the execution of the function ends. So for this particular case, all we have to do, well, I should line it up a little better, but that's not really a big deal. Car X, because X represents everything in my list. Car X, or car X's, I think that would really be the same thing, but we could do car X. Now let's see if this is okay. It compiles, which is good. So let's see, find, well, here, we could do define my list and let's see, 18129, 18129, 11.2.14.5, 11.2.14.5, 10 and 4, 10 and 4. Okay. Find maximum of my list. And that's going to be 14. Okay, so then Let's create a random list. Well, here, okay, so the function, I could just do random 100, and that's going to give me a number between 0 and 99. This will give me a number between, okay, 0, an integer, sorry, it's going to be an integer in this range. Now notice the interval is open on the right side, which means 100 is not included in the interval. So actually, it's going to give me an integer in this range between 0 and 99. So what if I want an integer between 1 and 100? Well, all I have to do is just add 1. Just add 1. That's easy, okay? So let's see if we can do this, okay? Define my random list for list, and you'll see what this does in a moment. I have to make up some identifier name. Well, I'm not going to use the name. Actually, what for list does, let me show you what for list does. For list I, should I do, well, let me see. In list range 11, display I times I. Oh, I should do, wait, okay, that's going to be a little hard for you to understand. So display okay, so what I'm doing, first of all, range 11, it produces a list of integers from 0 to 10, but it does not include 11, just like in Python. Python does the same thing. If you have range 11 in Python, it really produces, and you convert the range into a list. You get a list of integers from 0 to 10. So I'm only using the variable I. I could use another variable if I really wanted to. That's why you have the double parens. You could use another variable, but I'm just using one variable. Display ln times, I or I times I. And what we're really getting back is a list of voids, which is like the Java null or the Python none, because these are side effects. I'm printing to the screen, which is a side effect. So what I'm really getting back is a list of null actions or a list of nones. In Racket, it's called void. It's a list of voids. Okay. So I can do the same thing to generate a bunch of random numbers. Okay. So how would I do that? Let's see. Let's do it like this. Define whoops, this is not going to be a function. My random list for list. I'm just going to use, I'm not going to name my variable. I'm going to use the underscore because I'm not, I'm not going to reuse the name of the identifier or the variable. So in list range 100, okay, and then we're going to have +1 or 1 plus random 100. So let's display this. Display ln my random. Well, okay, that's okay. Actually, instead of 100, let's go up to, well, let me see. Let's go up to 1,000. And let's make this a smaller list. How about just 25? display ln my random list. Okay, what's my maximum? 794, let's see. This is my new maximum, 828. This is my new maximum, 874. This is my new maximum, 976. It looks like, if my eyes are not playing tricks on me, I believe this is the maximum. Let's see, let's check. This is gonna, okay, initially this is my max, not bigger. This is the new max. This is the new max, new max. And now I'm looking for something bigger in the tail of that list. So 382, 75, 435, 292, 382. No, okay, so I'm pretty sure 976 is the maximum of that list. Okay, let's 976, let's check it out. So I think the answer should be 976. Okay. Let's see. Find maximum of my, my random list. And the answer is 976. Racket is a little confusing at first, especially for people who are used to, Python and JavaScript, etc., etc. However, let me tell you something. Racket is nothing to sneeze at. It is a very interesting and very powerful programming language. It's not one of the more popular languages, unfortunately, but it offers a big punch. It has a lot of power to it. So let me just give you a quick example, and I'm not going to go into a lot of detail about why this works. Our videos, well, let me see if I can do this quickly. So we're going to make this list very big. 10,000. And the largest number, okay, will be, let's say, 1,000,000. 1, 2, 3. Okay. Let's do this. Find maximum my random list. This will take a little time. Oh, it faster than I thought. Okay. So I have a random list, 10,000 numbers, and they could range anywhere from 1 to 1,000,000, and the largest number is 999,952 in my random list. Now, how much do you want to bet Python is going to really have problems with that? So let's take a look. And Python will have problems with it. Okay, so IPython. Let's define that function one more time. Find maximum of x's. Okay. If the length of x's is equal to 1, just return x is 0. Okay. Else, the head of my list, okay, x is 0, and max value of tail is find maximum of, okay, the rest of the list. If head is greater than max value of tail, return head, else return max value of tail. I think that's okay. Let's make sure it works. Find maximum 1, 2, 3, 4, 5, 6, 7, 8, 10, and 9. Should be 10. Oh, I didn't, oops, sorry about that. I forgot a comma. Okay. So now from random, import randint. And you're going to see something really interesting happen here. My random list is equal to randint. Okay, what did I do in Racket? Okay, between 1 and 1,000,000. Randint between 1 and 1,000,000. 4 in range 10,000. Okay, this isn't good. Recursion error. Maximum recursion depth exceeded while calling a Python object. Okay, Python really is not a great language for heavy-duty recursion. We can extend that a little bit. But import system get recursion limit. I believe it's 3,000 stack frames. So we can change that. Set recursion limit. I'm going to make it 12,000, but you know, we shouldn't have to do that in a programming language. We really should not have to do that in a programming language. So for certain things, Racket is really more powerful than Python. All right, so let's try that again. Okay, 999,875. Now remember, in case you're wondering, why is this number different? Why is this number different? Because here, one second. Here we have the number 999,952, and here we have the number 999,875, not 952. So how come they're different? Well, remember, this is a list of random integers. These integers are random. So of course, you know, the maximum integer here is not going to be, the maximum integer in the Python list is probably not going to be exactly the same as the maximum integer in the Racket list. That makes perfect sense, I hope. Okay. All right, guys, I think our video has gotten long enough. I hope all of this is starting to make some sense. This is a mathematics course, but it's a mathematics course. How can I say this? This is a mathematics course that emphasizes algorithms and computation. So therefore, you can be sure programming is going to appear a lot in a course like this. All right, there's a lot of, there is going to be some programming in this course. I mean, maybe not a lot, but there's going to be some programming in this course. Now, some of the homework problems, you know, you can solve them with just paper and pencil. There are some homework problems you can solve them with just paper and pencil, okay? There are other homework problems where, honestly, you need a computer program to help you because, you know, there's going to be so much information to process. and you're not going to be able to process it just by using your eyes. So like I said, there are some homework problems that are going to be very easy. You should be able to do them with a simple calculator or paper and pencil. But there are other homework problems that are going to be more challenging and that will require some comfort with the basics of programming. Okay, so in this course, we are going to be doing some Python programming, some Racket programming, and hopefully some Mathematica programming as well, assuming Oakton renews its Mathematica site license, and I hope that they will do that. Okay, they should do that this week or next week, hopefully. Because there are some problems in the book that are better done with Mathematica. You could use Python, you could use Racket, but that can get very complicated, especially when we get to the chapter on graph theory. Okay, Mathematica has some fantastic functionality for analyzing graphs. Could you do it in Racket? Could you do it in Python? Absolutely, but it's a lot more work. It's much easier in Mathematica, okay? All right, guys, I think that is enough for today, and I think that's it. So let me know if you have any questions, and remember, at the end of the course, there will be 3 programming projects that are due. You have to pick 2 languages, Mathematica and Racket, or Racket and Python, or Python and Mathematica, or if you want to, you could use all 3, but you cannot use the same programming language for all 3 projects. You have to use at least 2 different languages for the 3 projects. And hopefully Mathematica will be one of those choices, one of those options. All right, guys, that's enough for today. Have a great day, and we'll communicate sometime soon. Be well, and that's it.